Okay, so hello everyone and welcome to this tutorial on matrices. I'm David.
And I am Michael.
And today we'll be talking about matrix multiplication.
Okay, so let's get right down to the basics. What is a matrix? Well, if you're hoping for something like this,
Trinity! Help!
Only human.
Dodge this.
then sorry, you are greatly mistaken. It's not related to the Matrix trilogy. This is more like what a matrix really is. Matrices, the plural for matrix, are rectangular arrangements of numbers, expressions, symbols, etc., which are arranged in columns and rows. Take this matrix for example. The numbers forming the matrix are called elements or entries of the matrix. There are 6 elements in this matrix. Every matrix is also made up of rows and columns. This matrix has 2 rows and 3 columns. We call it a 2 by 3 matrix. Matrices can be added, subtracted, or even multiplied together. When adding or subtracting matrices, they have to be of the same order. The image shows an example of addition and subtraction of matrices. In the next section, we will be covering matrix multiplication. So, now that we've learned the basics, let's move on to our main focus of today's video, matrix multiplication. This is what matrix multiplication looks like, but don't worry, it's a lot simpler than it looks. So, matrix multiplication is basically just multiplication involving matrices. It can be separated into scalar multiplication and multiplication of 2 or more matrices. Scalar multiplication is essentially just multiplying a matrix by a single number. For example, take a number represented by k. If it is multiplied by the matrix as shown, you arrive at a product, which is essentially just k multiplied by every single term in the matrix. And the image at the bottom shows an example of how this works. And so moving on to more complicated things, we will move on to the multiplication involving 2 or more matrices. And we must establish that there is a criterion for this. And that criterion is that the number of columns of the left matrix must be equal to the number of rows of the right matrix. And so evaluate which of the following matrices can or cannot be multiplied. Please pause the video for a while to complete this task. And so here are the answers for that task. We see that in part A, because the number of columns of the left matrix is not equal to the number of rows of the right matrix, it cannot be multiplied. The same can be said for part B. In part C, because the number of columns of the left matrix is equal to the number of rows of the right matrix, the matrices can be multiplied. And the same can be said for part D. And so here are some properties of what you get when you multiply 2 or more matrices. And do note that based on the picture on the left, matrix multiplication is non-commutative, which means that matrix A multiplied by matrix B is not equal to matrix B multiplied by matrix A. This can be shown on the image on the left. And also matrix multiplication is associative, and this can be seen from the 2 examples on the right, which show that no matter what way you group them to multiply the matrices, you will still arrive at the right answer. If you're still not sure about this concept, feel free to Google it.
Okay, so how do we exactly multiply 2 or more matrices together? So we can do this by finding the dot product of the rows and columns of the matrices. and we will be using the example below to explain the dot product method. So this actually looks very complicated, but in actuality it's quite simple. Basically, the dot product is where we multiply matching numbers and we add them all up. So for the first set, as we can see here, we are finding the dot product of the first row of matrix 1 and the first column of matrix 2, which is the values 1, 2, 3, and 7, 9, 11. And we do so by multiplying the matching numbers. So 1 matches with 7, 2 matches with 9, and 3 matches with 11. And so what we do is we take 1 multiplied by 7 and we add that to 2 multiplied by 9, and we add that again to 3 multiplied by 11 to get our dot product of 58. And so we do so by matching the first numbers, which is 1 and 7, and we do the same for the other values. And when we repeat this same process, we find that the dot products include 64 for the first row of matrix 1 and the second column of matrix 2. And when we finish everything up, we get our final answer with the 4 dot products of the 4 combinations as stated here: row 1 and column 1, row 1 column 2, row 2 column 1, and row 2 column 2. And we get our final answer of the multiplication of these two matrices. Okay, so the dot product method, as we just described in the previous few slides, it might be a bit confusing, and so this is a very simple and easy way to remember how we actually multiply these matrices, and it's very easily remembered as the run and dive method. So let's get straight to it. When we multiply using the run and dive method, basically it has two elements to this. Firstly, there's the run aspect, which is the left to right arrow as stated here, and there is the up down dive as stated inside the title of this method. And so basically what this method depicts is almost the same as the dot product method, and basically what it's matching is the first term in the first row of matrix 1, which is the one here, and it's being matched to the first term in the first column of matrix 2, which is -1. And so the same goes for the second term of the first row of matrix 1 and the second term in the first column of matrix 2. And these matched terms are multiplied and added, and we find that our dot product value, which we were to obtain if we use the previous method, is -5, and we can also obtain this using the run and dive method. And if we apply this further to the different columns, which when we do it systematically, this is how we do it. We do the run and then we do the dive here, and then we apply the dive for the different columns of matrix 2, and we repeat this process, and we find that for the second column in matrix 2 we get our final value of 13. And when we apply this to the other two columns, column 3 and column 4 of matrix 2, we find that we yield values of -6 and -19. And so what we find is that our current final multiplied matrix has these 4 values as part of the first row, because we have only done the first row of the run here. And so if we continue to do so for the second and third rows of matrix 1, we will arrive at our final answer right here. And so it's a very simple method. It's very easy to remember, and the moment you initiate it, you can get the answer relatively quickly, and I find it's also easier to remember than the dot product method.
So now that we have learned on matrix multiplication, here are some exercises for you to assess your understanding. Please pause the video for a while to try these out. So here are the answers. Please check and ensure that you got the correct answers. The last one was difficult. If you got it, then you have no worries about your matrices MR.
Okay, so finally we'll be going through some common mistakes that students make when they multiply matrices. So given matrices A and B, students tend to make the mistake that AB equals to BA, whereas in reality AB is not equals to BA, as the multiplication of matrices is non-commutative. As we have stated earlier on in the video, when we multiply matrices, it is both non-commutative and associative. The next common mistake that students make is that given two square matrices A and B which have the same order, AB equals to the product of the corresponding elements in the matrices. This is illustrated in the following example, where students tend to make the mistake that in the upper left hand corner of our resulting matrix, it's actually the product of 1 and 5 in the two matrices that we are multiplying together. And the same goes for the rest of the values, and this is a big error because matrix multiplication is very different from traditional multiplication, and we have to use our run and dive method to figure out that the values are actually 19, 22, 43, and 50. The last common mistake that students make is when we multiply a row matrix and a column matrix as seen here. So in actuality, what you're supposed to get is a 1 by 1 matrix. When we utilize our run and dive method, we find that this value is obtained when we multiply 1 and 4, 2 and 5, 3 and 6, and we add all of these values together to get 32. However, students tend to think that the resulting matrix is a column matrix, and they obtain the values inside the matrix by multiplying 1 and 4, 2 and 5, and 3 and 6, and instead of adding them all together to get the final value for your 1 by 1 matrix, they end up with the values 4, 10, and 18. So here are the sources we would like to acknowledge that helped us greatly during this assignment. Thanks for watching, guys, and if you found this video helpful, don't forget to leave a like, and I will see you next time. Goodbye.